Okay, welcome back to another session of our Audio Data Science class on machine learning. Yesterday we looked at data preparation and preprocessing, which is an integral part of data science and machine learning. You need to prepare your data and process it in a way that will make it possible to do data science and machine learning stuff. We looked at many things, including how we handle missing data and how we visualize some of the properties of our data, how we deal with missing values, the different ways in which Python and the libraries deal with missing values, the not a number, none, and none, its differences, and all of that. What I wanted to add is just a couple of more words that in many instances, the data that we have may not come in the form of numbers. And we all know from our introduction to computer science that computers only understand numbers, right? Zero and ones, they are binary machines. They understand numbers. So to be able to use to do machine learning, which is mathematics, I'm sure you've talked about that with Lukman and Dr. Shamsul in previous classes. Mostly what you'll be doing in machine learning is matrix, multiplication, tensors, and all of that, which is just mathematics, linear algebra. So to be able to do that, you need to convert whatever you have into numbers. So we have two types of data. We can see, generally, we can consider two kinds of data, the continuous data and categorical data. Continuous data are numbers, the normal numbers we have that have value. Let's say, for example, now, if I get data about people, their height and weight, that will come in numbers. That's numbers, continuous numbers. So, but we can also have categorical data, categorical values, meaning I want to take the data of people, their height and weight. I will just consider not the numbers specifically, but let's see, tall, short, medium. This is not numbers. So to be able to do any analysis with this, um, that has to do with mathematical computation, we need to convert it to numbers. So, and yesterday we looked at an example. If, for example, with this airplane, if this is a data representing the classes, we have business class, first class, and economy class, and we want to do any competition with this, we need to be able to convert this to numbers. One way to do that, we said, is label encoding, whereby each class that we have in our feature set in our data, each class that we have in our data, we represent it with a label. So it's called label encoding. And so that's what label encoding does. So that if you can replace this with numbers, any numbers, so that you can have it like this. Instead of your class to be this business class, whatever, we can say business class, for example, is 0. So anywhere we see business class, we put 0. We can say first class, for example, is 1 or 2. Anywhere we see first class, we put that. And then for the economic class, we represent it with numbers, and we need to use these numbers consistently. But we also said that this may have some limitations. If you have so many feature sets, so many classes, you may need to have different labels for all your distinct classes, and that may be problematic, and it's not as accurate. Okay, when somebody makes same place, it may not be as accurate as if you it may not be as accurate if you have so many feature classes. It makes the computation very difficult. So another way we do that is which is very efficient, very helpful technique, is the one-hot encoding, where we said what we do in one-hot encoding is we represent each class as a matrix of 1 and zeros, right? So meaning if we have a single column of feature like this. This we represent it as a matrix of equal number of distinct classes. So we make, if we have one column, it can become 3, 4 columns. Here we have how many distinct classes? We have business class, first class, academic class. So what we do is we represent this with um, 3 columns. Instead of this only single, this we have business class, for example, first class, and academic class as columns. So wherever we see um, business class, we make it 1, all other instances 0. So we did for all of it. So it's just a representation of 1 and zeros. Where it intersects, we call it 1. All other places, it's 0. So we can have something like this. Instead of having only this, we are left with something like this. 3 different columns representing our classes. And then we have anywhere it's in our original data, it's business class, so it will be 1. So all other places is 0, like this. So this class is represented by this 3 set of numbers like that. So this happens, and this has been proven to be more efficient, more accurate than label encoding. So in pandas, it's easy to do that. We use just get dummies, one encoding for your class. You define the class, the column that we want to do it for class. We've seen this. This is not very complicated. So what we don't, then the rest is easy, just removing duplicates and what are duplicates. So what we didn't talk about, what is not part of this class is, I think it's very important, is normalization, which is another very important component of data preparation and data preprocessing. So since we don't have it here, I will just see what I can remember from my head, but I will make sure that we do that before we start machine learning. It will be before any experimentation on machine learning. We will look at uh, because it will definitely be used. So we look at data normalization or scaling. So what does that mean? If you have a data, if you have a data with only single column of, let's say, height, right? Okay, let's say we have a data set of, let's say, a car. It contains the number of seats, the car, and then the maximum speed, minimum. Oh no, that is not like minimum speed. The maximum speed and many other information. So you see, if we have number of seats, I don't think there's any car that can. Let's assume the lowest is 2, 1. If we have a car with only 1 passenger, and then we can have up to 100 seats. Let's assume we have that much. I don't think so. So, but if we go to the column of speed, we can have up to 200 maximum speed and all of that. It is not even a very good example, but what I'm trying to say is, in machine learning assumes, generally when we are doing machine learning, if you want to do machine learning, it assumes all your data it's on the same scale, meaning in some instances your range of values is between, let's say, 10 to 1000, and in another scale it may be between, just for example, 0 to 10. But the machine learning will assume they are all on the same scale. So when you do any prediction, any machine learning task, it will all consider them to be on the same scale, meaning 10 in, for example, height is the same as 10 in speed, which is not true. It's different scale. So to be able to, the first thing you need to do before you do any of your machine learning, after all your preprocessing, you need to make all of them on the same scale, so that your machine learning does not confuse and put all of things together. So we have many ways to do that. We'll look at that, but luckily you don't have to worry much of it. Libraries can do that for you. We have standard scale and all of them, just one line of code. But you just need to know that whenever you have a data having multiple columns and each of them are on this different scale, you need to do normalization. Otherwise, your computer can assume they are all on the same scale and that will give you whatever accuracy you get, whatever metrics you generate will be wrong, will not be accurate. So do we have any question before we move to uh, visualization?
Assalamu
Yes,
alaikum.
Wa alaikum salam.
So my question is not like related to this the lecture, sir. My question is pertaining to the certification course.
Okay.
So in the one that the explanation they did for us yesterday, the course was called data scientist certification. But when I went to the data camp, the certification that I saw was data scientist associate certification and one data scientist professional certification. I don't know if the two of them are the same or it is a different one, sir.
It's the same, but now I think it's I will just take at the end we can take questions about all of that, but now let's take questions about what we did, what we are doing now.
All right,
Salus,
so thank you.
yeah, does your question involves what we are doing right now so that we preserve time and have time for
Yes, sir. I just need some a little more explanation for that normalization that you just spoke about now.
Okay. The problem is I don't have any resource on it. It will be easier if I show you example, but I don't. I'm surprised that. Okay. I will try to explain again. Okay, yeah. Even look at this. You can see my screen, right? For the visualization.
Yes, I can see.
Yeah.
Yeah, you can see we have multiple columns here. You can see this for this maximum body mass, we have numbers in thousands, all of them in thousands from the head the top five. Even here is enough, for example, while here we have in the hundreds, right? Not more than 100, not up to 1,000 from 70s. So when
Yes.
you want to do machine learning with this data, the computer, the algorithms generally assume, you see, this is bigger than this, but it doesn't mean this is more important than this because they are on different scale. In this column, minimum wingspan span, 135 is a very big number because it's the highest number there, but it's a very small number here. It's inconsequential here. It won't do much effect here compared to here, right? So, but the computer will assume, the machine will assume all of these numbers are small numbers. So they will not give them importance because these numbers are bigger or somewhat like that because it assumes they are on different scale. So to be able to do any machine learning task with this, you have to make sure that they are on the same scale. Everything on your within this will be on the same scale. So if you do scaling of this, all of these numbers will not look, they will change. Depending on what the minimum and maximum of that column, the minimum and maximum, oh, that's one way to do it. The minimum and maximum of this column, it will convert all of them to the same scale.
That is like 0 and 1.
It's between 0 and 1. That's one way to do it, yes. All of them will
Okay.
be within that scale, yeah.
Okay. Thank you.
So, unfortunately, I just saw this. I was looking at this morning. For us here, it's still morning. It's 8:20 a.m. now. In the repo, we don't have the data set for today, so you will not be able to. You will not be able to do this access until we push the data. Somebody will push it. If you have access, please push it for us. Otherwise, I may do it later. But you don't have in our repo we don't have this data set, and you need it. So, but we'll put it right there. It's unfortunate, yeah, but we'll put it there so that you will be able to do it. I just saw it this morning, and yeah. So, and what we have here is not is nowhere complete for visualization. But take it as the beginning point, the starting point to most of the wonders and many things that you could do with this. So we we are starting with visualizing quantities, seeing the quantities we have. Normally, we use data visualization for two purposes. One is for exploratory data analysis, where we want to explore our data to see what is our data. We did data processing. We used data processing yesterday to do some of that. The data set.head, data frame.head.tail, describe.info, and all of those methods, functions that we used. So we can also use visualization, especially many things that that method cannot show you the numbers. We need to visualize. It's one way to do that. We call it exploratory data analysis to explore. And then also at the end, we can visualize our results. That is the second thing we can do with it to see our result in a more, you can have your accuracy, precision, or recall all your root mean squared error and all your square error matrices in absolute error. But at the end, what does it mean? How does it compare to the others? You can compare them by head, but it's easier if you visualize the comparison, how each quantities are related to one another. Yeah, so we'll be using this data set, and then we will be using there are many libraries you can use. For the purpose of this class, we only use the matplotlib library that you need to install it if you don't have it. You can do I don't know what, during your introductory Python, what they teach you for installing libraries, but you can use the pip install matplotlib, and then you can install it, you can import it as you do with pandas and numpy. Import matplotlib whatever as PLT, or you can do it as anything, actually, depending on what you have. So this is our data set, buds.csv. It will be within a data set. We don't have data set for any experiment within this, our repo. It will be in the folder that the name of the folder is data. So it will be within that folder. If you clone, I haven't cloned the repo. That's why I have mine different. If you clone the repo, then you can use the notebook as is, the codes given, but otherwise you have to make sure that your data set is in the appropriate place. Otherwise you'll have error. So when we visualize our data set, we can see we have the first five. We can see this is the head. We have multiple columns in our data set of beds, the name of the bed. Eventually, we will change this data set to reflect whatever we have in our location. So this is not American kind of beds. Some of them, we don't have them. So the beds, their scientific name, their category, all of these biological things that I have no idea on. The status, if it is endangered, least concerned, like all of this we have in the head, they are least concerned. Nobody is interested about them being extinct. And then we have properties about their size in numbers. Their minimum length, maximum length, their mass, the minimum mass, the maximum mass, the minimum wingspan, I think, if they open their wings, and that. So this is what we have. So if we want to visualize this, we can just do a normal line plot to see what our data is. Just, yeah, for example. So we can just, for example, we want to plot this, maximum wingspan. We pick the column with wingspan equals to beds. We pick this column as this, and then when we plot it, so this, we are plotting this data as a line plot. That's how we do line plots. Please mute yourself, or somebody should mute him. So this is what we have in our line plots. And one of the first things you will observe here is we have outliers. And this is one of the good things about visualization. It's very easy to spot outliers. See the size of this is sizes, right? The maximum size. So we are having things in the hundreds, and then all of a sudden we have something of 2,500, 300, and thereabout, and maybe another one here. It's unlikely to have a bed of this size. This is in what? Okay, I don't know whatever scale, but maybe centimeter. it's very unlikely to have something, a bed of this size. It's like a dragon, right? So it's possibly an outlier. So what we could do is, okay, what do you notice? Maybe there seems to be an outlier. This is quite, okay, yeah, it's centimeter, 2,300 centimeters. So it's unlikely we have, yeah. So one way to do is to know what is here. If we know the bed that has this span within our data set, we can understand, we will know the bed. If it's a dragon, okay, we say that's correct. If it's not a dragon, then we say which bed is this that has this size. So what we could do is we could add, because here we just plot the values. So we can try to plot the type of beds in the x-axis so that we can see what it is. And then, so this is how we put PLT. We already import multiplot as PLT. So this is how we put our title, PLT the title. This is our title. And then this is, we can put Y label and X label with this. So this will be our X label, no, Y label, and this our X label. And you can see, oh my God, what can we read from here? Because we have so many values, so many different kind of bets within our data set, it's not possible to read anything. So what we did here, whatever we did here, it's not going to help us. And we rotated the X ticks, meaning these are the ticks in our plot, and in matplotlib, the column ticks, we rotated for each bed 45 degrees so that we can have more space, but notwithstanding, we just can't see whatever we are doing. So even though the rotation of the labels is set to 45 degrees, there are too many to read. Let's try a different strategy. Label only those outliers within. So since we cannot use this to see, and then, but we are only interested in our outliers, so we can use a different type of plot. Instead of using line plot, we can use scatter plot, and then to put the label of only outliers. And we know our outliers, possible outliers, are all over 500. If you look, right, this one is over 500, this one is over 2000. So, but everything less than 500, we can assume it's somewhat accurate. We don't have many things over even 300, but we can put threshold of 500 or 300. What we have in the text is 500, but I think even 300, okay. I don't know where this is, but to be safe, it's good to say 500 because it cut across evenly. So we can do the same plots. We having our title, our Y label. So generally, you may be trapped with things that you don't understand. I don't know how much you've been told about this. It's always a very, very good convention to read documentation. It's easy to know what Y level is. It's easy to know what title is. It's self-explanatory, but when we see PLT, the tick prompts, you may not know what it does when you're doing your study. So it's good to just see, don't say PLT, see matplotlib tick prompts. You can read documentation, then it tells you what this boot means, what this boot means, what this false and true means. So it's easy for you to grasp. So anything you see, any method that you don't know, what does it mean? Instead of just, you said, okay, I know they just put it there, let me just copy and put, also it works fine. It's good to read documentation. The easiest way to know it is, it comes from the matplotlib library. So you search matplotlib from tick prompts, then you can read the entire documentation on that. So this tick prompts is used to, is the tick parameters. It deals with these ticks, these numbers, and even the lines. So you define. So here we are defining properties. The axis we want to modify on both axes, both Y and X axis, and then which I also have to read this. It means we have, minor and major tick. These are the major ones, and then we may have the minor ones, the ones that are inside here to make up to this. So whatever you are defining is for them. So which label? This is for which label? So we label bottom false. So we are removing everything down. Bottom also false, meaning in essence what we want, we don't want major, minor ticks or anything down. We are not interested. Like what we have here, which some of things are there by default. If you plot them, they will just come by default ticks. So now we are saying we don't want them to take them out. And then we plot using scatter plot. So a point for each of our data set. That's what scatter plot is, just plotting a dot or whatever for each data point from our data set on the plot. So we loop it, and then we plot based on the name, the mean span, the maximum wingspan. That is this. So, and then we are using the bow. This you can also read. This bow is stand for this giant blue tick we have. So we want this kind of tick. There are many other arguments that you can try. You can read. You can look at more arguments that you can have here. So we see if our at any point, which is point I, right? Because we are starting with I from 0. So if at any point our index is greater than the value of our wingspan is greater than 500, meaning if we are plotting and then we have any instance that the value of our I is bigger than 500, meaning sorry, this and this, then we want to plot text. We use plot text if we want to write something, right? So the name at I, because we already defined from the very beginning, our I will change. We define our name from the name of the data set, name of the bytes in our data frame, and then this, and they will move in together based on I. So the moment you have any instance that it's more than 500, so you want to write the name of that instance, this is the font size. So this generally what it means is whatever you have for your Y, meaning the wingspan, um, you make it a very small. This is not necessarily actually. We want to plot it very close to the point. If we don't do this, then it may come on top of it, or it may block it. It actually happened here. So we want to avoid too much of this. So we make the number slightly smaller. Whatever number is there, we make it slightly smaller. And this we did. This is just mathematics. This will result in a number that is slightly smaller than the original number we have. Whatever number we have there, this will be slightly smaller, and the name will be plotted there. This text will be plotted there. So we want to plot a text very close to the point, not too far, close to the point of the name, so we can see which bits are there. And then so we have this as our scatter plots, and you can see we have the bald eagle and falcon. Both the eagle and the falcon are nowhere close to the size. I think we have from our data frame is this one is 2000 whatever 300, and this one is 1000 maybe 100. Most likely we just added a 0. So here instead of 2300 is 230, and here is 100 plus or thereabout. The falcon is slightly smaller than the eagle. So what's going here, we use the tick parameters to hide the button labels. We created the loop, then created a loop over our beds. There's a plotting chart, the chart with small round blue dots using the bow. You checked for any bed that have an outlier, meaning that has a maximum wingspan of 500, and display with a dot. The dot is our bow. Then we offset, meaning make it a bit smaller on the y-axis with this. So yeah, so now we are able to clearly see what we have. So we move to another segment, which is filtering our data. So now that we know we have these outliers and what our outliers is, we have the options of filtering them out. We can discard them or we can correct them. Meaning correct, we can assume it's an addition of zero. They will fall down to within the context of our data set, but we need to filter them because visualizing this like this does not give us the variation among our data sets. So because of the outliers, or else we'll have more. Here we cannot see most of the data points here. We're just see a line. It doesn't really tell us much because of the scale. Instead of our scale to be, let's say, between 0 to 500, we have our scale between 0 to 2,000 because of only two instances, two data points. So we don't need these data points. We can just discard them or we make them into they fit a scale that we can be able to see our data set better. So that's why we need to filter our data. Both the bald eagle and the falcon, while probably very large birds, appear to be mislabeled with an extra zero added in their maximum wingspan. It's unlikely that you will meet of that. It's not unlikely, actually, it's impossible, except if it's a dragon. Excuse me. It's unlikely that we'll meet whatever. Yeah, so what are we doing here? Okay, yeah, we are just filtering out. We are using this, we are just plotting the same bed, still removing what we did previously, removing the tip params on the below. And then we are using the same scatter plot, so plotting. There is a different way we can do scatter plot. We can just do plt.scatter. But this especially because we are trying to filter out. So we are plotting if the name of the bed at point I, at our starting point, going forward at any point, rather, it's not bald eagle, it's not the falcon. So here we just exclude these two instances. And you can see we have a more, we can visualize now the data points more clearly, they are spread and whatever. This is more readable as opposed to having this that we don't know which, we don't know. The only data points we can read out is this if we name them, or in this that we don't really know what we are looking at. So here we can see our distinct data points and we can see our concentration. We have most of the bets are within this concentration. And of course, we have small bets. So by filtering out outliers, your data is now more cohesive and understandable. And at this point, it's important to point out that you see the effect outliers has on our visualization. So this is the same kind of effect or influence it can have when we want to do machine learning. With outliers, it affects your learning process, it affects your result and whatever. It's very important to deal with them. And you wouldn't know they exist unless if you do visualization, you try to see them and all of that. Not that we have a cleaner data set, at least in terms of wingspan. That's the only thing we are touching for now. Let's discover more about these bets. While line and scatter plots can display information about the values of and their distribution, we want to think about the values inherent in the dataset. We want to think about the values inherent in the dataset. We could use to the specific values, meaning the specific values. We could create visualizations to answer the following questions. How many categories of bets are there? Yeah, what we have with scatter plot, we cannot do that. And what are their numbers? How many bets are extinct, endangered, or rare? Because that's part of the information we have here. You see, we have this classification that conservation status that tell us things about their conservation status, if they are endangered, if they are rare, if nobody cares about them, meaning they are less concerned. We have many of them like the tabara. Nobody will be worried that they are whatever. And how many are there of various genus or in whatever that term is. So we can use bar chart, right? Meaning bar chart is very good for visualizing or grouping data. And that's what we are interested. Actually, we say categories, what categories we have. So grouped. So we can use bar chart. Bar charts are practical when you need to show grouping of data. Let's explore the categories of bets that exist in the dataset to see which is the most common by number. Yeah, so that is how many is number, and then it's one of the very good ways to visualize numbers in terms of grouping. How many? We use bar chart. Note that you can either filter out these two outliers like we did in the previous section, or you can just correct them within the data set. Yeah, but you can do whatever you want, but it's better you don't correct it. It's better you leave them. You can just change the it from the CSV file, but you don't do that. Leave it because of your playing and experimentation, so that you remember. Otherwise, you even forget that the data has an outlier. If you want to create a bar chart, you can select the data you want to focus and whatever. So we have our buds, which is our data dot plot. What do we want to plot on the x-axis? We want to what we want is category. Which kind of plot do we want? We want bar chart. We want it stacked, for example, meaning we want all of them in the same line. And then the title is Bed of Minnesota. But we are back to where we started. If we do this, we cannot understand anything within this because this is not telling us anything. So we have to do this in a different way. The bar chart is, however, auditable because there are too many non-group data. You need to select only data that you want to plot. So let's take the length of beds. If we are plotting the entire data set, which really does not mean anything. We cannot plot the entire data set. So to be able to visualize, we want to select a specific category that we want to see the group data within that category. So let's look at based on the category. Filter data to include bets, only bets category. Notice that you use pandas to manage the data, then you can do the matplotlib. Like you can use a matplotlib for plotting. Okay, so now first of all we start by defining a new variable called category count, and then we count the numbers of the value count of bets in our category. If we come here, we have category column. So we want to count the numbers we have in our category. So now we plot that. So for each category that we have here, we count its number value point, and then we plot that as horizontal bar chart plot. We have this. If we use bar, it will be vertical, but if we use bar H, we will have the horizontal bar chart, and we have this. Even this is plenty of categories, but you can see all of these bets have very small numbers. This is more readable, meaning for that category, we know the numbers we have. We can see dogs, gigs, and waterfall. We have more than 40 different categories of that. For this, we have this much different and all of that. This bar shows a very good view of the number of beds in category. In a blink of an eye, you see that the largest number of beds in the region is this kind of Agwagwa, right? Minnesota is the land of 1,000 lakes, so this isn't surprising. If you go to different places, desert or whatever, we may see this different kind of birds. And you can do, this is just for this category. You can try other counts on the data set. You can count any different number, any different, this within, maybe within this, to see whatever you have as your exercise. And then we have this, we are visualizing only one feature, one column in our data set. We can compare more than one. So you can compare different group data by creating new axis. You have one on the, let's see, y-axis, and then you can also have one on the x-axis, and so that you can visualize what happens if it changes. Does it affect the change? So what do we do here? So we are plotting, we want to take the max length of our bed, and then we are plotting the max length and the category within our data set, and then we are setting the figure size as 6 by 12. So what we can see now, we can see this is, we can just see the number. This is the exact number of what we have. We can observe, this is the size of the bed, maximum size of each bed, and this is the bell categories, their number. So for example, we can see these homing beds are the ones that has the smallest in size. They are the smallest, this is in terms of centimeter, and this is not surprising at all. Homing beds, the smallest beds. I don't know what kind of beds are this or this. But of course, this is not surprising. Ducks, agwagwa, not even the normal agwagwa, like the geese that we know. Geese, they are the largest. And yeah, they are one of the largest kind of birds that we have. Not surprising at all. The hummingbirds have the least max length compared to geese. It's good when data makes logical sense. It's good when data makes logical sense. You can create more interesting visualization with bar charts by superimposing data. Okay, meaning when you have two different, this we have only the maximum, we can have both the maximum and minimum on this plot. That is superimposing values. So let's superimpose the minimum and maximum length of a given bed category. So we have the minimum length. We are picking the minimum length, the maximum length, and then the category. And then we plot it 2 times in our chart. We plot the category and the maximum length. In the same chart, we plot the category and minimum length. And then the moment we plot it, we show our plot. You can see we have for every bed, which we have first, we have its maximum length and its minimum length. So this is very easy to also understand. This is the minimum length for geese, and this is the maximum length for geese. From here to here, minimum for geese, and this is the maximum. So it's good, especially we don't have to plot 2 different plots, one for minimum, one for maximum. We can just impose it together and have that. In this plot, you can see the range of minimum, maximum. You can simply set given data. Excuse me. In this plot, you can see that the range of per bed category in minimum length and maximum length, you can simply see that this data is a bigger bed, the larger, whatever. You can know which bed is bigger. You can know it's the range of its values, the minimum and the maximum, and all of that. You can go and try this. Unfortunately, we have 2 problems here. You have to do all of this on your own. That is, the notebook is empty, but it's good. You can just copy, look at it from the repo, and then do. But we don't have the notebook is empty. Actually, you have to do all of this on your own. And then, as I've mentioned, we don't have the data set yet. Yeah, So, any question? Am I audible?
Yes, sir,
Yes,
you're audible.
Oh, okay.
you're audible.
Yes, sir, you are audible.
So I wanted to make sure if you can hear me. So do we have any question? So someone asked a question um, regarding what was your question again? Can you ask it again regarding what was mentioned yesterday by Dr. Shamsuddin regarding the data camp certification, right? Can you ask the question again?
Yes, sir. My question was pertaining to the certification course, sir.
Mm.
When I went to the data camp, there's one application like that, data camp, that I downloaded from Play Store. I saw a list of certification courses there, sir.
Okay.
Yes, when I went there, the one that doctor showed us was data scientist certification. But the one I saw there was data scientist associate certification and one data scientist professional certification. And these two, in fact, like they're only like somebody have to like subscribe, like pay money like that, like that.
So what I don't know, have you been enrolled in the fellowship? Did you come?
Yes, enrolled.
Yeah.
No, sir, no, sir. I'm not enrolled in the
Did you
data
apply?
camp. Yes, I applied this thing. I applied, but I'm yet to hear any response, sir.
Okay, so I will let Bala answer you. He's the one. Bala, do you want to answer his question? He's the one managing the thing.
Okay, sir. I already made it clear in the channel that everybody that applied should have DM me with his full names and the email address so that I can enroll him. So it's possible maybe he haven't sent the information.
Yes, I didn't send it. I will do that, sir.
So it means you are not enrolled yet, so you cannot see whatever we are providing for free.
All right, sir. I will contact Bala privately, DM privately, sir.
So any other question? Bala, I will send that to you directly. Yeah.
Yes, sir, I do have a question.
Okay. Did you say anything?
Yeah, sir, concerning the visualization with Matplotlib, I don't know, is there a way for someone to do his visualization with maybe Power BI and kind of export it to maybe a notebook instead of maybe someone using Matplotlib? Because it's like, it's kind of easy, using Power BI than using the Matplotlib. Or does one have to just use the Matplotlib for the visualization?
Okay, I will answer your question in two ways. First of all, it's not difficult to use Matplotlib, and not even Matplotlib. We have another library that you should use. That's why I said this class is not in any way complete. The Seaborn library. So it's not difficult. You just have to.
Okay.
It's very easy, and all these plots, most of them the plots are already available. You just have to plot it. It's quite easy to do. Actually, you don't have to do much for any kind of plot that you're
Okay.
wanting to avoid. You can get. That's one way. It's not difficult. Then number two, I can't imagine a scenario where you want to do the plot because plot is just for visualization. So you don't need it if you are not plotting it in your notebook, you don't need it. Maybe you want to include it in publication or in your website. So you need it in the website or whatever place, but not in your notebook. I don't know how you can, I don't know how important that is in your do, but if you are preparing a notebook, if you are preparing a notebook like to teach people or to discuss things like
Yeah.
that, then you can add it using Markdown. But that doesn't do really anything. Otherwise, I don't imagine a scenario where you will need to import It's other than just any way that you can
All
import
right.
image in a notebook. Yeah, and as Bala has said, if you try this class, you
All right. I understand.
and you continue trying, it's easy actually, and you'll love the flexibility of the things you can do with it this way. Thank you very much for your question.
All right, sir. Thank you, sir. Thank you, sir.
Okay. We'll try to upload the dataset folder within the by today. In the repo, I'll try to push it. I didn't clone that's why well, and then you can practice. But I think in the meantime, if you are in a hurry, let me drop the link. If you are in a hurry and we haven't pushed it yet, you can get the data from the original repo. I have to go now. I have another meeting, but so but I seen the data is already in the repo, in the channel. So probably he's referring to your Telegram channel. So that's good, everyone. But I will not to send in paste the link here, as you have known. Yeah, Lukman has shared it. So you had Lukman has shared it in the resource channel. I've not been following that, so you can just get it there and then practice all you have. So I will download these recordings for today and yesterday, and I will put them in on the GitHub repo. And then happy studying, happy practice, and thank you for your time. Have a pleasant day.